Okay, so we have a lot of things going on now. A world has been set up. Well, just a list with one room, and then we have an object in that room, and then we have the player character in that room, symbolized by numbers, and it's not all that complex, but the elements are starting to add up in a way where interesting things could start to be put together. One of the interesting things, of course, would be interacting with the world. So, in a simulator, interactions, especially in this turn based setting that we're in, happen through, well, just like many other things that are starting to happen, like the program realizing that I'm in the same room as an object is happening through evaluating the numbers and declaring that if my location and the ID of where an object is are the same, then we are in the same area. So similarly, anything else that's going to come about is going to be the same format, a whole bunch of evaluations that express all these abstract ideas. Like in this episode, this video, I'm going to aim to interact with the fireplace or the objects that can appear in the world. In this case, we're just going to do simple, if there's an object, then we're going to have the ability to generically interact with it. And then the generic interaction will turn a off or on switch, off or on, true or false, and that will have an effect that we'll get to see in the world. So an interaction between us and the world. Let's start working on that. I'm going to need a list every turn of what the player can achieve, like all the actions that have become available. And that list will be updated every turn. So if I'm in a room that has some interaction available, then the list will pick up on that interaction and it will store the fact that I have that available. And then that will open up like a menu of all the objects that I can interact with in that manner. But then if I leave that room, I need to update that list. I need to check to see, is it still available that you can do that interaction? And then it will find that if I leave a room that had an interaction available, like turning on the light and turning off the light, and then I go outside, then the interaction will update and find that I can no longer turn on or turn off a light switch. And that dynamic list is going to have just numbers, whole numbers, just like all the other things, like location and the tag for objects. We're going to use integers to shift through or to tell the computer what interaction ability this is. We'll just call it act tag, or we'll just call it act. In this case, we could have the fireplace be lit or put out. And that could be the interaction with this specific object. Just to exercise this ability of interacting with objects in the game. So it's a good example to frame some code around, and then we can add more and more stuff. I'm thinking of how I'm going to set this up. Again, I don't have it all figured out beforehand. So over here in this set of code, it indicates that we are in the room with that object. And I'm just going to place the number 1 into the act dynamic list. So if I'm in the room with the fireplace, then I get this action available. Now every turn it's going to find every turn it's just going to want to add that number into the list if I'm there, if it finds that I'm in that room. So I need to make sure that list is fresh every time. I need to erase all the items within the list so that it can be updated and not start to have duplicates. So to make sure the list is refreshed every turn, I'm going to, at the beginning of the narration function, I'm going to just go ahead and erase the list. And what this does is I'm asking the program to erase the vector, the dynamic list, and I'm asking it to erase from the beginning. So you can call like this is the first item in the list, and then it goes all the way to the end. And then I just .end is a function to tell the computer like the last item in the list. So I'm just erasing everything in the list every turn so that I can update what's most relevant, what I can and can't do. So now I would need the object to have an on or off state. And since objects are going to be a shared class with many different types, like one object could be an arcade machine, another object could be a fireplace, and both of those are represented through the numbers. Like 1 can be a fireplace number 2. If the tag is equal to 2, it could be an arcade machine. And since that's happening, I need more dynamic lists for all the various states that could be represented with those objects. Like an arcade machine might have a is it broken or is it not broken effect, and a fireplace might have is it on or off. And to represent both of those, or one object might have many stats, many different internal variables, and the other one might have less internal variables. So to represent all this, we just need a dynamic list. So you could have dynamic lists of true or false variables. You could have dynamic lists of integer variables, and these dynamic lists can be used to accommodate how many attributes you might have. And then you don't go and create something like if you don't have a dynamic list, then you would need to declare every variable the object could have, and then you limit yourself. So having dynamic lists instead of doing this where you declare variable 1, variable 2, variable 3, variable 4, it's more convenient. And then over here, when we were declaring this object, we're going to go ahead and update the list. So the first position, no, we're gonna need multi-tools. Hold on. So this class that I'm declaring here is going to be a multi-tool, which has the attributes integer, a Boolean variable, and a string variable. So it just has, right now, 3 items that you would commonly need, and then a tag. And the tag is going to be the identifier. So what I mean by that is, if the object is a fireplace or an arcade machine, then in the dynamic list over here, you only need one list. You just need this. So we're going to have a dynamic list of multi-tools, and then the tags will identify what it means. So you could have the multi-tool 1 in the fireplace, and the tag 1 in the multi-tool will mean, like, is it lit, or is it put out? Is it on or off? And then the arcade machine might have a multi-tool with the tag 1, and it will symbolize, is the electronics, is it broken, or is it working condition? And then it might have another multi-tool, but you see, you're going to have the ability to add attributes and associate those attributes with the tag, and then it will make sense in context with what the object is representing. So that's how the computer is going to be. Well, it'll make sense as I start to add in more features. Like, I'll be walking through these examples one by one on why this is a very effective method in the long run versus all the other ways I could have simulated this. I'm trying to build a catch-all simulator that makes additional whatever we add on. It won't take a lot of like reworking of the code. It'll just seamlessly, fit into what's already been developed. And that's what I form a lot of my how I structure the code around. I try to make it as open-ended as possible so that any idea that comes up isn't going to immediately conflict with any hard-coded setup that I have. The way I'm setting it up right now, you can really express a whole wide range of behaviors. Whereas if I just took the easy route and just described some idea and then coded directly to that idea, I'd be locked in. Every idea that I had, I'd be completely, well, yeah, a lot of rework, a lot of extra coding would go into it. I'm going to end this part here, and then I'm going to have a far clearer idea of how to, well, I'm going to show how the player can interact with the object. All right, in the next video.